This is your note packet. Again, we're going to have three of these this semester. So please keep this because it's going to follow what I put on Google Classroom too. It'll have the video on there and it'll have the answer keys and everything. So we're going to do this algebraic expressions, right? So we turn to the first page here and it says 1.3 notes day one. Okay, so I don't know what kind of math teachers you've had in the past, so I'm going to use some terminology here that I hope you guys at least heard before, but I want to make sure that you understand my terminology, okay? First of all, when I talk about an algebraic expression, first of all, algebraic means it has a variable, right? So we're looking for an expression that has a variable. Now, what's the difference between an expression and an equation? Okay, what do we do with expressions? Yeah, you just write it out and you make it easier or simplify it, right? So algebraic expressions, you simplify, or sometimes they'll give you a number to plug it in, so that's you're actually evaluating some expressions, right? If they give you a number to plug in. Now, what are equations? What's an algebraic equation? Well, just the word equations. Equal sign, right? So equations have an equal sign. And you're going to solve for whatever variable it is, whether it's x, y, v, the problem tells you, right? So you're going to solve for the variable. Or what we mathematicians like to call it, isolating the variable, right? Isolate the variable. Did you ever hear that? So that's really what you're doing with an equation. You're isolating the variable. Of course, if I could spell it right. So that's an equation. And what we mean by isolating variable, like x equals a number, right? X equals 0 or x equal 2, something like that, where you have that isolation of that variable. A couple of other things that I've come across the years, and even when I was in high school, I never had a teacher actually explain the terms. And then when they would start using the terms, I didn't know what they meant. An expression, let's see, does anybody know the difference between terms? What has to be in between terms? Because this got me for years. I don't know why. Term has to be separated. See, separated. That's why I became a math teacher because I can't spell. Has to be separated by a plus or minus sign. I don't know if anybody ever told you that. Um, a constant or a constant term. Well, let's talk about this. A coefficient. Okay, let's look at this positive 10k. A coefficient is a number that's being multiplied to the variable. So this 10 here is a coefficient. Because it is a variable being multiplied by a constant or a number. By the way, how many terms does this expression have? K plus 9 plus 10K plus 1. How many terms? 4 terms, right? See how this gets all confusing? And especially if I don't explain it right off the bat, because it'll be 2 weeks in there and I'm saying, hey, there's 3 terms, take this term, multiply this quantity by this coefficient. You guys, what is he talking about, right? So these are, I'll be using these terms. And a lot of times I will not explain myself. Okay, one more thing that we come across that sometimes students don't know. What's in parentheses separated by a plus or minus sign? What do we call that? Oh, I think I heard it. Quantity, right? This is a quantity. So, I'm hoping at first, like I said, I hope to explain it while I'm doing it. But a lot of times I don't. And I just use these terms and I don't want you to get lost. Okay, now we can talk about the variable expressions. Okay, this is one expression. There are 4 terms consisting of 4 expressions. Expressions can have multiplication and division in the same term. This is called an algebraic expression or a variable a term, I should say term, because it has k. So I have 2 variable terms. Numbers only are constant terms. So I have 2 variable terms and 2 constant terms. We can simplify this because they're like terms in this. So I have this 2 variable terms. By the way, if I don't have a coefficient in front of a variable, what is it? 1, right? So I have a 1k to the first, and a 10k to the first. I can combine these, right? Because they're like terms. Okay, 1k, a positive 1k, and a positive 10k gives me 11k, which is a teacher's salary for a year. No, I'm just kidding. And then I have a constant term, a plus 9, and a plus 1 gives me a constant term of 10. See how easy it is? Now you think algebra 2 is going to be because we just did an easy one. All right, next one. Let's do number 4. Okay, first of all, you have 4 terms, right? 1, 2, 3, 4. I have 2 constant terms, 1 and -5, or plus and -5. 2 variable terms. So I'm going to combine my variable terms because the a has the same power of 1. So a -4a. Notice how I include that sign with it. I do that. Even when I use distributive property, I always include the sign in front of it. Okay, so I have a -4a. I'm going to combine it with a -3a because they're both a to the first. And I have a -7a to the first. And then I do have some constant terms, right? +1 and a -5. So that gives me a -4. I'm simplified. That's as far as I can go. That's my answer. Okay, number 5. Again, I have 4 terms. 1, 2, 3, 4. I have 2 variable terms. I have a positive 9v to the first, a positive 3v to the first. Gives me a positive 12v to the first. If you want to put a plus out there, go ahead. And then I have 2 two constant terms, a positive 2 and a constant term, positive 4. Combine those, I get a positive 6. There's my answer. I hope I didn't insult your intelligence too much. Okay, so now the next thing, that you probably learned in Algebra 1 was if you have a number in front of a quantity or in front of parentheses. What do you do with this? Multiply, right? Multiply over the parentheses. What's that called? Distributive. Okay, I think I spelled it right too. Okay, so I got a 6 times a positive 1k gives me positive 6k. Then I'm going to take that 6, multiply it to a positive 4. Now, I like to include the sign in front. You guys may have been taught to bring the sign down and carry the sign over here, however you want to do it. So I have a 6 times a positive 4 gives me a positive 24. I can't combine any terms. They're unlike terms, so I'm done. Okay, what if I have a negative 6 out in front? That's the same thing, really. Negative 6. I take that whole negative 6, multiply it by a positive 8, gives me a negative 48. Then I'm going to take that negative 6, multiply it to a negative a. Negative times negative is a positive. And then I have a 6a. Man, Dawson's already doing that to me. What's your name?
Elena.
All right. So that's that. Nothing to combine, right? All right. Let's do number 10 right underneath it. Okay. I have a negative 3k. Going to multiply it by a positive 1k. Negative times positive is a negative. 3 times 1 is 3. K times k this time. K squared, right? Okay, negative 3k times a negative 2 is a positive, let's see, 2 times 3 is 6k. That's it. Do not combine these. This is k to the first, k to the second. They're different, unlike terms. Questions? Okay. And of course, now we get back to our distributive property and distribute and then combine like terms. So, number 11, I'm going to distribute 8 times a positive 9n, positive 72n, 8 times a minus 10, because that's the way I do it. I do it with the sign in front. 8 times a minus 10, so minus 80. Now this is outside the parentheses. Don't distribute that 8 to the 4n. Just bring that 4n down. And this time I do have n to the first plus 4n to the first. So 72n to the first, 74, so 76n to the first. And then I have my minus 80. So a little bit more complicated, not too much. Let's do number 14. Negative 3x times a positive 1x negative 3. Now x times x is x squared. When we multiply, we add those exponents. Negative 3x times a positive 4. See, negative times a positive is a negative. 3 times 4 is 12. And then I have that 1x. Then I'm going to bring down this one because it's outside the parentheses. 7x squared. Now the x squared are like terms. So I have a negative 3x squared. I'm going to combine it with a negative 7x squared. Negative 10x squared. This guy is by itself. It's an x to the first. So nothing to combine there. Okay. That's my answer. And then, of course, take it one more step farther, two distribution expressions, then combine like terms. Okay, let's do 16. 3 times negative 6b, negative 18b, 3 times a positive 10, positive 30. Okay, go to the next distributive problem. Positive 7b times a 1b to the first is a positive 7b squared, right? B times b. And then we have a 7b times a minus 8. So positive times negative is negative. 8 times 7, 56, and there's a b there. We good? Combine our like terms. Well, I only have the 1 squared, so that guy's by itself. 7b squared. Let's see, I have, here's some b to the first, right? The negative 18b to the first and a negative 56b to the first here. We're combining, we're not multiplying. So negative 18 minus 56 could be a minus, 60, 74? B. And then my constant term here is a plus 30. That's it. Question? No, good. So you've got your little homework sheet there, your practice worksheet. You only have 10 problems. I didn't give you a whole lot of time to work on it. However, I like putting, I try to give you as many answer keys as possible. Okay? Because a lot of students, and this is a valid mathematical technique. Sometimes when we get into harder problems, you can work from the answer backwards. That's why I try to give you the answer key. But don't just copy it to the front. You're better off just leaving it blank because that tells you you didn't do it yet. And I'll keep going over more and more of the classroom rules and Google Classroom in the next few days, okay? But that's my teaching style. If you really think you're going to have a hard time with it, I'm okay with you trying to find another teacher, really. I'll even help you. But this is what I have. I have a document camera, and that's all the technology I have. So, any questions? Okie dokie.